Today we're going to talk about memory versus storage in terms of programming in C and C++ and many other languages too. The main difference between memory and storage, and the main confusion that results from this difference, is that storage is the space where your apps, files, pictures, and documents reside. And what this means is that storage is the place where things sit that are not currently in use. So your documents, pictures, files, and apps are things that kind of just sit around on your storage because you downloaded them, or you took the picture, or you stored the file. And those things stay static. They're unmoving. They aren't being used currently. And memory is for things that are currently being used. And what this means is that when you open up a file or an app or something like that, you're going to load some of it into memory, because memory is much faster than storage. The technology we have for random access memory exceeds that of storage when we're talking about random and quick access. Storage is huge, but it's also slow, while memory is fast but small. So memory is small storage. Now the way we solve this problem that memory is so small is that it is temporary. And when I say temporary, let me fix that. When I say temporary, I mean that when you load an app up on your phone, it needs to run super quickly, right? So it's responsive, because when we're programming things, we want things to be responsive for the user, because that makes it more appealing to the user. And to make things more responsive, it's got to run very fast, which means it's got to talk to the computer, it's got to talk to the device, it's got to exchange information very quickly. And we can't do that on storage, because storage is very slow. But with memory, we can. So what we can do is we can load some of the data that needs to be quickly exchanged into memory, and then when we're done with it, we deallocate or remove that memory from our RAM. And this brings the idea of that temporary effect that memory has. Data only exists in memory for short periods of times when it is being used. And the best way to explain this is by just opening up Task Manager on the Windows operating system. So right now we see that 40% of my device's memory is being used, and it says right there, physical memory in use by active processes. And if we go over here to performance and check memory, I've got 7.7 gigabytes available. Currently 3.1 gigabytes are being used. And what this means is that the apps open on my computer, including all of these background processes, apps, all of that good stuff, and my system is loaded into memory, because things like Task Manager need to be interacted quickly with by the user. And for instance, my sketchbook program, which I'm using to show you this drawing application, is using 97.8 currently megabytes, and that's fluctuating. As you can see, it's fluctuating very quickly. And the reason for that is that it is deallocating and reallocating memory that it needs to perform certain tasks during runtime. Now, this is not my storage fluctuating. It's not the size of this application. It is simply the memory that's in use currently right now in runtime. So that's the main difference between memory and storage. This application takes up a static amount of space on my disk. It's unchanging size on my storage unless I update it or add something to the program. But when I open it, it's going to be constantly changing in memory to account for what I'm doing in the application. And other applications, like the broadcasting software that I'm using right now, is going to use a little bit of memory, and Microsoft Visual Studio is going to use a little bit of memory, and all of these things add up to make that 39% memory figure out of to be a total of 3.0 gigabytes out of 7.7 gigabytes on my system. So when we're dealing with programming, we want to make sure that our program doesn't use too much memory, because this will slow down the computer. If this number reaches close to 90%, my computer is going to be very slow, because what that means is that other programs don't have access to the memory, because the program that we made is using it. And this will slow down the other programs in my computer as a whole, because my system is also loaded into memory, and if this system, aka the operating system, slows down, then everything else will too. So when we're programming, we want to make sure we clean up memory after ourselves. We want to make sure we don't hog memory. It's a valuable resource. And we want to make sure that our program doesn't leave any memory behind. And these are just important things that you need to know going into learning programming languages. And it's the fundamental idea of data exchange on your system and how you should manage your program. All right, that's all. Thank you.